Hello, in this video I would like to explain about the conditional probability. The conditional probability definition says probability of B given A, if A and B are two events, probability of event B when event A has already occurred will be the probability that A and B together occurring divided by the probability of the event A. Let's find the conditional probability using the formula P of B given A as P of A intersection B by P of A. Consider the experiment of tossing two coins. The sample space will consist of the four elements head, 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 tail, tail, head, tail, tail. Let A be the event when you get at least one head. So A will consist of those three outcomes head, 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 tail, tail, head. B is the event when you get two heads, that is B is just head, head. So the intersection of A and B, the common elements between A and B is just head, head alone, just one outcome. So probability of B given A, according to the definition, it is P of A intersection B by P of A. A intersection B, I have 1 out of 4, which is the probability. P of A will be 3 outcomes out of 4, 3 by 4. So when you simplify, you get that as 1/3. Or in other words, when we are trying to find P of B given A, we are looking for how many B's are there in A. I have got only one B here out of those 3. We can also find the conditional probability using the Venn diagram. Now, if I have a Venn diagram like this, where I have got the intersection of the two sets A and B as 2, and only in A I have 1 and only in B I have 3. So if I'm trying to consider what is the complete set A, will be the events just outcomes 1 and 2. B will be outcomes 2 and 3. A intersection B is 2. So probability of A given B will be P of A intersection B by P of B. In other words, it is 2 divided by the total outcomes of B are just 2 and 3 outcomes, 2 plus 3. So it will be 2 by 5. We can also find the conditional probability using the two-way table. If the data are given using a two-way table, we can also find the conditional probability like in this case. It talks about the number of times students visited the tutoring center where they are full-timers and part-time students. If the question is, what is the probability that the student visited the tutoring center 4 or more times given that the student is full-time? So the student is full-time is given already. So that is your event A say. And B is the event when the student visits the tutoring center 4 or more times. So in this case, the full-time student is my event A, and this is my event A, and 4 or more times, that is my event B. So if we are trying to find the probability of B given A, so P of B given A will be P of A intersection B by P of A. P of A intersection B is as shown in this diagram. It is 8 out of the total 58. P of A will be the number of full-time students here is 45 out of 58. So when you simplify, you get that as 8 on 45. So to simplify the whole calculation here, we can say that P of B given A, that is when you are trying to find the probability of students, those who have visited the tutoring center 4 or more times, given that they are full-timers, is the same thing like what we are looking for. Number of students who have visited the tutoring center only among the full-time students. So there are 8 who have visited the tutoring center 4 or more times. Among the full-time students, 45 students. So it is 8 out of 45. We can also find the conditional probability using the tree diagram. Let's see this example consisting of 5 balls, 3 red and 2 blue. Out of this 5 balls, if we are picking 1 red ball, then the remaining will be just 4, 2 red and 2 blue. If you are picking 1 blue ball, then again it will have 4 balls where 1 blue and 3 red. So the probability of picking 1 blue ball from this bag of 5 will be 2/5. Picking a red ball will be 3/5. Now, having picked the first one as blue, suppose if we are picking blue ball again from those remaining 4, we'll have the probability as 1/4. Or if we are picking a red ball, it will be 3/4 from this first set. Having picked a red ball initially, if we are trying to pick a blue ball for the second time, it is 2 out of 4. Or if we are picking a red ball again, it is 2/4. So if I have picked a blue ball and again I'm trying to pick another blue ball, then we will get the probability of picking 2 blue marbles will be 2/5 multiplied by 1/4, which is 1/10. So this first one is probability of picking a blue ball, and this is probability of picking another blue ball. So the second one, this is nothing but probability of picking a blue ball, provided that I have already picked a blue ball. The second one is a blue, provided that the first one is blue already. So we have P of B given A as 1/4, or when you multiply these two, P of A will be P of B given A. In fact, this is nothing but when we use the formula P of B given A as P of A intersection B divided by P of A. So when you multiply these two together, you get that as P of A intersection B. So this 1/10 is nothing but P of A intersection B. So in this video, we learned about the conditional probability, and we also calculated the conditional probability in various methods. First, we used the formula, the direct formula to calculate it. Second, we showed a Venn diagram, and using a Venn diagram how to calculate the conditional probability. Third, we talked about a data, a table, and using the bivariate table, you can also calculate the conditional probability. The next one, we showed a tree diagram. Using the tree diagram also, we can easily calculate a conditional probability. So hope this video was helpful to understand what a conditional probability is. Thank you for listening, and thank you for watching. Thank you.